Now for tutorial question 2b, again we have an algebraic fraction on the left hand side and a 0 on the right hand side of the inequality. So there is no need to shift anything from the right hand side to the left hand side. Okay, so the first thing we should do is again check which values of x for which the algebraic fraction is undefined. In this case, we will have to exclude x to be 3 and 4. Okay, so the next thing we will need to do is to multiply both sides by a suitable positive expression. Okay, and the purpose of doing this again is to change the inequality to one involving entirely of polynomial expressions in x. Alright, so in this case, for the factor x minus 4, take note that this power here on the factor is even. So for this part, we can just multiply both sides by this expression itself, since this is always positive. But on the other factor, we see that this is 3, which is odd. Okay, so for this part here, we will need to multiply by the next even power, which is power 4. Okay, so we would multiply x minus 3 holding the power of 4 and the fourth power of x minus 4 on both sides. Okay, so this would simplify to actually x minus 1 multiplied by square of x minus 2 multiplied by x minus 3. Alright, to be greater or equal to 0. So x minus 3 to the power of 4, once you have multiplied x minus 3 to the power of 4 on both sides, you will cancel off with the 3 in the denominator to give you a power of 1. Okay, so let me label the powers on each of the factors. Alright, whereas for x minus 4 to the power of 4, it will just cancel off with the denominator entirely. Okay, so now let us draw out the number line, since this is already in complete factorized form. Okay, putting in all the roots 1, 2, and also all the values of x for which the expression will be undefined. So in this case, with 3 and 4. Okay, so now since this is non-strict, the inequality is non-strict, we would include all the roots, okay, except for the points where for which the graph is undefined at. In other words, 3 and 4. Okay, then we sketch in the graph accordingly. So we take a arbitrary value of x. Okay, a good choice is always 0 because we can calculate very easily. In this case, after your calculation, you should see that it is positive. Okay, so what we should actually get is a graph that looks like this. Okay, the graph will now cut naturally at x equals to 1 because the power corresponding to this factor, the corresponding factor is 1. Alright. Now for 2, this is a turning point because the power is 2, okay, which is an even power. And for the remaining root, again, it will cut naturally at 3. Okay, so now we want to observe where the graph is above the x-axis because we are looking at greater or equal to 0. So that will corresponding to everything here, here, and do not forget, which is a point that is usually forgotten, the root itself, x equals to 2. Okay, so the final conclusion should be 0. No, sorry. Okay, so x is less than 1, less or equal to 1. Alright, or x equals to 2, or 3 is strictly less than x, strictly less than 4. Remember, we cannot include the values of x at 3 and 4, or x greater than 4.